Welcome to our channel. Ever wondered how Netflix knows exactly what you want to watch, or how Amazon remembers your last order? Behind the scenes, all that magic starts with relational databases, the backbone of data analytics. Today, we're breaking down RDBMS and showing you how it powers the data-driven world around us. Every time you shop online, stream your favorite show, or even check your bank balance behind the scenes, a powerful system is working to keep data organized, accurate, and accessible. That system is the Relational Database Management System, or simply RDBMS. Today, we're diving into how RDBMS forms the backbone of data analytics.
1. Basic database terminology. Before diving deep, let's get familiar with basic database terminology. Tables. These are like spreadsheets where data is stored in a structured way. For example, a customer's table. Columns. These define the type of data stored, like customer name or email. Rows. Each row represents a single record, like one customer's details. Understanding these basics is the first step to becoming a confident data analyst. 2. Relational model basics. Now, let's talk about the relational model, the core concept behind RDBMS. In this model, data is organized into entities, attributes, and relationships. Entities are objects or things you want to store information about, like customers, orders, or products. Attributes are details about those entities, like customer name or order date. Relationships define how entities connect. For example, each customer can have multiple orders. This structure allows data to be connected logically and efficiently, enabling complex analytics.
3. Importance of data integrity and constraints. Data integrity ensures that the information in your database is accurate, consistent, and reliable. To maintain this, RDBMS uses constraints such as primary key, a unique identifier for each record, like customer ID. Foreign key links records between tables, like connecting orders to customers. Not null ensures a column always has a value. Unique ensures no two records have the same value in a specific column. These rules prevent errors, maintain relationships, and make your analytics trustworthy. 4. Why RDBMS is essential for data analytics. RDBMS is crucial because it allows analysts to organize large datasets efficiently, join related tables to combine information, aggregate and summarize data for reports and insights, ensure accuracy and consistency through constraints, use SQL to query and extract meaningful insights easily. Whether you're analyzing customer trends, sales performance, or financial metrics, RDBMS is your foundation.
5. Examples of popular RDBMS tools. MySQL, open source, popular for web applications. PostgreSQL, advanced, flexible, and open source. Oracle Database, enterprise-grade and feature-rich. Microsoft SQL Server, reliable for corporate environments. SQLite, lightweight, ideal for mobile apps and small projects. No matter the platform, the principles of tables, relationships, and integrity remain the same. 6. How analysts use RDBMS daily. As a data analyst, you'll use RDBMS to query data with SQL for insights, join tables to combine datasets, clean data and remove duplicates, aggregate data to calculate trends, averages, or totals, feed dashboards with reliable, real-time data. RDBMS allows you to transform raw data into actionable insights for decision-making.
To summarize, tables, rows, and columns are your building blocks. Entities, attributes, and relationships define how data connects. Data integrity and constraints ensure your information is accurate and reliable. RDBMS is truly the foundation of modern data analytics. If you found this useful, hit the like button, subscribe, and share with other aspiring data analysts. And tell us in the comments, which RDBMS have you used or are excited to learn?